So hello everybody, welcome to this important series of constraint motion. We are dealing with the 10th problem in the constraint motion series, and in this problem we are asked to establish a constraint relation for the system as shown. You can pause the video and attempt the problem over here for yourself and then continue watching. You can refer to the previous videos in order to understand how to solve it. We will again be solving using the virtual work done method, or where we will be using tensional analysis followed by the dot product of T and A and then equate it to 0. So if we begin with the tensional analysis, we can say that over here on this block a tension T, we start from here. So T, and in all the connecting threads we say that the tension is going to be same. So we will obtain something like this. So over here I can say that a 5T tension, 1, 2, 3, 4, 5T tension is acting on the block A, and A is moving in the forward direction, that is opposite to the direction of tensional force. So we can say minus 5T times of velocity of A, so VA, and then over here we can say that a 2T tension is going to act here and 2T tension is going to act here on the shaft of this pulley, and then plus 4T velocity of B, and this is equal to 0. So from here we can say that 5 times VA is equal to 4 times VB, and if I talk in terms of acceleration, then 5 times acceleration of A, that is if we differentiate this equation with respect to time, is equal to 4 times acceleration of B. So now in the problem, acceleration of B is to be determined, which is written in the problem as A, and this is equal to 5 times acceleration of A, which is A0 by 4. So acceleration of B can be written as 5 times A0 by 4, and this is the final answer for this particular problem, or the 10th problem in the series which we are solving.